Now I want to discuss with you one problem where we will use the result Sn of geometric progression. How many terms of GP 3, 3 by 2, 3 by 4 are required? That is such a type of how many terms are being summed up to get the result 3069 upon 512. We do not know how many terms when sum up and answer will come this, a required answer will come. Let us assume we need n number of terms. So let n terms are required. Let us n terms are required for finding the sum is this. That is, first term is 3, then 3 by 2, then 3 by 4, then up to how many terms? N terms. When n terms of this GP are sum up, answer must be equal to 3069 upon 512. That value of n we are looking for. What is the answer of A? First term is 3. Common ratio R is half. This is A, this is R. Because 3 by 2 upon 3 is half, 3 by 4 upon 3 by 2 is half, and so on. So here the answer of common ratio is less than 1. We will use the result Sn is equals to A 1 minus Rn upon 1 minus R. Reason is very simple, because common ratio of this GP is less than 1. Sn, how much should be the sum? That is 3069 divided by 512 is equals to, what's A here? 3 into 1 minus, what is R? As calculated, half. That's to the power n upon 1 minus R means 1 minus half. 1 minus half is half, and then simplified 2 will go in the numerator. This becomes 6. So 3069 upon 512 is equals to 6 into 1 minus 1 upon 2 is to power n. As 1 minus half become half, and that half has gone in the numerator, multiplied to 3 gives us 6. When this 6 transferred here, we get 3069 upon 6 2 is 12, 6 1 ja 6 carry 1 7, then 6 5 ja 30. 3072 is equals to 1 minus 1 upon 2 raised to the power n. This, when negative will shifted in the left side, what we will get? 1 upon 2 raised to the power n is equals to 1 minus 3069 upon 3072 is equals to, the simplification of this gives us 1 upon 1024. 1 upon 2 is to power n is equals to 1 upon 1024. What implies this? This implies 2 raised to the power n is equals to 1024. 1024 can be written as 2 is to power 10. So I can say it is, that is 2 is to power n is equals to 2 is to power 10, which implies on comparison that n is equals to 10. So what we can say with this solution, that 10 terms of this progression are required to make the sum of this GP as 3069, hence answer is 10. Now one more problem that is based on how to find the sum of any GP up to infinite number of terms. It is only possible to find the sum of geometric terms up to infinity if mod R, that is common ratios mod, is less than 1. We have 1 is the first term and the common ratio is half. We know that S infinity is given by A upon 1 minus R. What's A here? 1 upon 1 minus R means half. This become 1 upon 1 by 2. So S infinity become 1 into 2 by 1. That is what? 2. So sum of this decreasing geometric progression up to infinite terms is how much? 2. How? As we have explained by using the formula S infinity is equals to A upon 1 minus R. Now I want to discuss with you another problem where we will find the sum up to n terms, but the problem is bit interested. Say for example 7 plus double 7, triple 7, 4 times 7 plus dot 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 up to how many terms? N terms. Using the concept of geometric progression, find the sum of this series. In fact, the series written is not GP, but there is a process with the help of what? We can convert it in geometric progression. Question raised, how? I just would like to explain you here that first term is having only single 7. Second term has 2 7s. Third has 3 7s. Fourth has 4 7. So how many 7s will be there in the nth term? There will be n times 7. Single 7, if I say, I can write it as 7 multiplied by 9 divided by 9. So what you are understanding? You can say it is 7 by 9 into 9. There is nothing wrong in writing the 7 in this form. Which can I say? It is 7 by 9 into 1 9 can be written as 10 raised to the power 1 minus 1. Okay. If there are 2 7s, what can we do? We can say 7 7 into 9 upon 9. Again I can write, if 7 is taken out, 9 is taken out, if 77 is written as 7 into 11 and that 11 is multiplied by 9. So this becomes 7 by 9 into 99. This double 9, 99 can also be written as 10 square minus 1. This is the value of 77. We can check. If there is a triple 7, if triple 7 is multiplied and divided by 9, there is no change. If 7 is taken out, 9 is taken in denominator. If 777, that is 777, can be written as 7 into 111. And this 7 I have taken out, this 9 denominator, this 9 and triple 1 when multiplied, we will get triple 9. Can be written as 7 by 9 into 10 cube minus 1. 7 by 9 into 10 cube minus 1, this become. So if 777 is up to how many times? N times, that can be written as 7 by 9 into 10 raised to the power n minus 1 with the observation, with the pattern which we are noticing, that single 7 is written as 7 by 9 into 10 raised to the power 1 minus 1. Dual 7 is written as 7 by 9 into 10 raised to the power 2 minus 1. Triple 7 is written as 7 by 9 into 10 cube minus 1. So obviously 777 up to n times, where n is a natural number, can be written as 7 by 9 into 10 raised to the power n minus 1. So this was my purpose to tell you that how we will convert the given series into geometric series. So I am writing it as I have explained you 7 by 9 first become 10 is to power 1 minus 1, double 7 as 7 by 9 is out, this become 10 square minus 1, triple 7 become 10 cube minus 1, plus dot dot dot, last term become 10 is to power n minus 1. I can say it is 7 by 9, 10 is to power 1 plus 10 is to power 2 plus 10 is to power 3 plus 10 is to power n. What's here? Minus 1, minus 1, minus 1, minus 1 in each term. That is in each n term. So I can say it is minus n. Clear cut, this is what? This is GP 10, 10 square, 10 cube with first term 10 and common ratio 10. So this become 7 by 9. A r is to power n minus 1 upon r minus 1 minus n can be written as 7 by 9 into this is 10 is to power n plus 1 minus 10 upon 9 minus n, because 10 is multiplied. If I take the LCM and 9 will become here, this will be 7 by 81, 10 is to power n plus 1 minus 9n minus 10. So this is the sum up to n terms, though the progression was not AB, was not GP, but it was expected that it can be converted into GP for finding the sum up to n terms, which is written here as.